and they still had like 15 minutes to work on their homework, which was 10 questions on Math Excel. That Math Excel I have set to be due at 3 o'clock today. So after 3 o'clock, then it will deduct late credit. Are there any questions on the Math Excel assignment right now? So just make sure if you don't have that one done, that you get that caught up, and if you need any help, just let me know. So the thing that I started from section 2 yesterday was interval notation. It was the last part of the video. It's talking about a new way that we're going to write our answers. So you guys are used to writing things like -1 is less than or equal to x is less than 1. Interval notation, instead of using the inequalities and the x, it just gives a starting and a stopping point. What this means is you want things bigger than -1 and smaller than 1. Okay? Last year you would have used a closed circle at -1 and an open circle at 1, and then just shade in between. Interval notation, you have to go left to right, small to large. So -1 is my starting point here. If you can equal something, it gets a square bracket. So we're equal to -1, so it would be a square bracket. -1, comma. Where does this end? At 1. We're equal to 1, or sorry, we're not equal to 1. If you're not equal to something, it gets a parenthesis. So you just go left to right. You always have a starting and a stopping point. Bracket if it's equal to, parenthesis if it's not equal to. Okay, so let's look. I've given some intervals, and I want to see if we can turn these into inequalities. I'm just making sure we can go back and forth between the two different notations. So this one, if you need to, you don't have to draw a picture, but it can help. You can use open and closed circles on your number line, but we tend to, in this class, since we're using interval notation, we're going to switch. Instead of open and closed circles, I'm going to do parentheses and brackets, just so I'm consistent. So it was a bracket at 1, parenthesis at 4. We're just talking about the things in between them. So how would you write that as an inequality? Less than or equal to x is less than 4. Okay, B, 2 to infinity. So that sideways 8 is an infinity, just means it keeps going forever. Infinity, you can't equal infinity, so it will always have a parenthesis on it. So what inequality would describe this? Everything bigger than 2. So I would write
Greater than.
x is greater than 2. It doesn't get an equal to because we had a parenthesis. Okay, C. That's kind of more like A because I have a starting and a stopping point. How would we write that one?
2 is it less than or equal to x? And less than 3.
And the 3 also has an equal to because of the bracket. D. Negative infinity to negative 3. So what that's saying is you had everything in the negative direction. We had all those numbers. How would we describe that? Yep. No equal to because We don't have a bracket. Any questions on that one? The next piece that we're talking about today is functions, what it means to be a function. So you've heard the terms function and relation before. A relation is just any kind of correspondence between two sets of numbers. You know, typically we think x and y. If it is a function, what's true? Somebody remember? Function is a relation where x never repeats. So each time you put in a number, you get one and only one answer out. So we're going to look at some relations and try to decide if they're functions. If I talk about domain and range, domain is which variable? And range is y. Alright, so we're going to be identifying domains and ranges as well. Let's look at these examples. So A, I gave you a table of values. I'm asking if it's a function, and if it is, we're going to give the domain and range. Is this one a function?
No, because x never repeats.
Yeah. Your input is like your x, your output is like your y. If I'm looking at this, I have the same x twice, so this is not a function. Okay. B, I gave you a list of ordered pairs. Is that a function? All you have to look at are the x's. Is every x different?
Mm-hmm.
Yes, so this one is a function. My domain. What numbers make up the domain?
1, 2, 3, 6.
Range is your y's. Y's can repeat in a function, so that doesn't matter. If it shows up more than once, you still only write it once in your range. So my range would be 4, 5, and 10. So even the 4 is repeated, just write it the one time. Right, is C a function?
No.
Why?
Negative 3 is repeat.
Yeah. I had the same x value twice. So that would not be a function. Alright, D. Instead of a list of ordered pairs, I gave you this thing. It's in set notation. It says the set of xy. It's just meaning it's all ordered pairs. That vertical line means such that y equals x minus 2. Okay, in other words, I gave you the equation for something instead of the list of all the ordered pairs that would work. We have to find the domain and range for that and decide if it's a function. So just look at this. If it's a function, then each x only gives you one y value. I'm going to plug in for something for x and subtract 2. If you take a number and subtract 2, do you ever get 2 different answers there? No. No matter what number you pick, you subtract 2 and you get 1 and only one answer, right? So x will never repeat, so that means it is a function. Domain. That's what x can be. Is there any number I can't use for x? Is there anything I could plug in where I can't subtract 2? No, you can subtract 2 from anything, can't you? So in the past, you would write all real numbers for that. If we're using the interval notation, what that means is on the number line, everything gets shaded. So interval notation goes left to right. From the left, it's going forever in the negative direction, so that's negative infinity, comma, it also goes forever in the positive direction. That's positive infinity. Infinities always get parentheses. So in the interval notation, that's how we write all real numbers. Negative infinity to positive infinity. The range, talking about my y's. Can I get negative answers for my y? If you do something minus 2, can you get negatives? Yeah. Can we get positives? Yeah. Can I get 0 for an answer? Is there anything we can't get then? So my range would be negative infinity to positive infinity as well. Any questions on those? I want to practice looking at graphs and giving the domain a range. So I'm going to put some different graphs up here. This one is kind of hard to tell. It's actually just 4 points on this graph. So the domain, those are your x values. You just have to tell me the x value for those 4 points. So what would it be?
4, -2, 1, and -1.
Does it matter what order you list those in? No, you just take each point and the x. So -2, -1, 1, and 4. How do we get the range? The y's. So if I'm starting down here, this one has a y of, then we had -2 and 4. Okay. B. I have this circle. Okay, am I just going to be able to list out the numbers that hit my x and y on this one? No. We are going to give an interval. Domain refers to your x. So when you do the x, you're going left to right. So think about, if you just took a piece of paper and we're traveling left to right. What is the first x value we hit? -1. Do we touch it? Yes. So would it get a parenthesis or a bracket? Bracket. -1, comma. My circle is hitting everything between those. What's the last thing I hit? 5. And parenthesis or bracket? Bracket, because we touch it. Range is the y. So going from the bottom up, the lowest point on my graph is at -4. We touch it, so it gets a bracket. I'm hitting everything until I get to 2. And it gets a bracket. I just have this line. Domain. As I go from left to right, this end is extending to the left forever. This end will extend to the right forever. So eventually it's going to hit everything. So what would I put for my domain? Negative infinity to positive infinity. Infinities always get parentheses. Okay, this, but looking at my y is going from the bottom up, so this is going down forever. That's going up forever, so eventually it hits everything, so my range is same thing. D. We have a parabola. So our domain. As this parabola keeps going, it gets wider and wider and wider. So from left to right, it's just spreading out. So eventually, we'd hit everything. So what's my domain?
Negative.
Always go left to right, negative to positive. Okay, my range, talking about my y's. If I'm looking from the bottom up, I'm not hitting anything down here, but right here my graph starts at 0. It touches it, so 0 gets a bracket, comma, then it goes up forever and it never stops, so that would be infinity. Any questions there? How do you tell by looking at a graph if it's a function? Remember, there's a really easy thing we look for.
If it doesn't touch.
You can't repeat your x. Do you remember talking about the vertical line test? If x doesn't repeat, then any vertical line would only touch it once. So if it's a function, it always satisfies the vertical line test. If you can draw at least one vertical line that hits your graph more than once, you get to say it's not a function. Okay, so I'm going to put 4 graphs up here, and I want you guys to just take a minute and decide if they're functions or not. So just jot it down on your paper, and then we'll talk about it. So decide if these are functions. Okay, is the first one a function? Yes. Second one? No. You can draw a vertical line that hits it more than once. Third one? Nope. You can draw a vertical line that hits it more than once. This one, it does look like it's kind of turning into a vertical line, but it's not. It's just flattened out for a second. So is that one a function? Yes, that one is. Okay, so that last graph, it might have looked a little bit like it turned into a vertical line, but it really wasn't. It was just increasing a little faster right there. All right. Let's talk just a little bit about function notation. And I have a couple examples with that, and then I'm done for the day. So in function notation, that's when instead of a y, you have an f of x. Okay, if I said like f of 2 equals 13, then what that means is, as an ordered pair, what's the x value? Two. F of x. The number in the parentheses is your x. So my x value is a 2, comma, the whole thing equals your y, so my y is 13. So it's just another way we can use to write equations. Instead of a y equals, we might see an f of x equals. That just means it's a function. Or we can look at it from ordered pairs. So I just want to take a couple and make sure we can evaluate. So for each of these, I want to find f of negative 1. So A, when I say f of negative 1, what is that telling me to do?
Substitute negative 1 in the
Okay, so order of operations, negative 1 squared means negative 1 times negative 1, so that's 1. And 2 minus 9 gives us negative 7. Okay, B, when I say f of negative 1, that means your x is negative 1. Tell me what the y equals. So what is it? Let's give you a set of ordered pairs. This is the point where my x is negative 1. What's the y? 6. So f of negative 1 is just saying if x is negative 1, give me the y. Tell me the y value in that ordered pair. Okay, C. This is a mapping. So f of negative 1. When my x is negative 1, the y is 5. We're looking right there. And D. My x is negative 1. So if I go to my graph, when the x is negative 1, we're right there on the graph. What's the y value right there? Approximately. Something between 0 and 1. Are those okay? Last slide. Here's my function. F of x equals 5 minus 2x. And we need to find each of these things. So f of 4, what is that telling me? X is 4. So 5 minus 2 times 4. That's 5 minus 8. Negative 3. F of A just says x is going to get changed to an A. So that's 5 minus 2A. You can't do anything with that, so that's our answer. If I said f of a plus h, what am I doing?
5 minus 2 parentheses a plus h.
Good. Those parentheses are important because what do I need to distribute through there? 2. Yeah. In fact, let's make it a negative 2. So if you take a negative 2 there through there, you get a negative 2a and a negative 2h. So we can plug in numbers, but we can plug in variables as well. The last one, f of 5x. So that would be
5 minus 10.
yeah, so you get your 5 minus 10x. Do we have any questions right now? So this is the end of our section. Just to recap, yesterday I did section 1.1, so you have that Math Excel. It's due at 3 p.m. today. Okay, after that you can still work on it, but it will deduct late credit. Today there is a 1.2 Math Excel. I think yesterday's prop was like 6 questions. I think today it's like 10. This is due at 3 p.m. tomorrow. Tomorrow is your online day. I am going to try something a little different. You have to watch the section 1.3 video. It's like, I don't remember, 27 minutes or so. There is a Math Excel assignment you can start, but it is not due yet. So I don't see you guys on Thursday, but the group I do see Thursday. We're going to do just a couple little things at the beginning of class, like 10, 15 minutes worth, and then they're going to have class time to work on that assignment since it's a longer video. So if you guys can watch the video and then you can start the Math Excel, but that one won't be due until 3 p.m. on Friday. So if you, that'll be kind of your Wednesday and Thursday is doing that assignment. And then Friday, that would be a good time, since I do see you guys Friday, you've worked on it and maybe you did all, but you didn't know how to do one problem. Then at the beginning of class, when I say, are there any questions, you can ask me about that one problem. So make sure you've worked on it so you can do that. Any questions about this? So you've got about 15 minutes right now to work on your